Hey guys, okay, in this lesson we are going to talk about aromatic compounds, what they are, and how they work. Benzene, the molecule C6H6, is the basis for aromatic compounds. They're traditionally called aromatic compounds because they had a particular set of smells to them. They're very odorous compounds. But as we started to understand the chemistry of them, we learned that they're actually quite interesting in terms of their chemistry as well. So if we look at benzene down here, it has 6 carbons that are arranged in a ring, kind of like cyclohexane did. But the difference here is that there are double bonds between every other carbon. You might say, okay, well, it's a cycloalkene. But it's not. Because these double bonds are arranged every other carbon, the electrons that are part of the double bonds don't actually live between these 2 carbons exclusively. They'll spend half their time here and they'll spend half their time here. So the double bonds end up being alternating. They spend some of their time between these carbons, but they're going to spend some of their time between the opposite pairs of carbons here. So the benzene molecule looks like this as well. And the double bonds are alternating between this state and 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 this state. And that's an idea called resonance. And that leads in part to very, very stable molecular structures because these alternating double bonds are very effective at holding the molecule together. And they're resistant to attacks from other molecules that are trying to chemically react with this one. Now, because this is a unique structure, we'll sometimes draw the structure like this instead. So instead of drawing single bonds and double bonds, we'll draw a dotted line here. Can't do a very good job of that on the computer, but a dotted line here, which represents a 1.5 bond. And there are some other molecular situations where we see 1.5 bonds or resonance bonds like this. Or we'll also sometimes draw this structure as a ring in the center. And that represents as well those alternating double bonds, because they aren't really single bonds, they aren't really double bonds. So really, this kind of representation or this kind of representation is a better representation for benzene than either of these. Now, benzene molecule has this resonance property, which leads to it being very stable. And you're going to find lots of aromatic compounds in the body. Because they're very stable molecules, living things have used aromatic structures to build various compounds, including things like hormones in the body. Now, here's a little bit of a note about aromatic compounds. They aren't technically saturated or unsaturated, so they don't fit into either category. So if we were asking you, if we gave you a list of molecules on a test question and said, pick out the ones that are saturated, you wouldn't pick an aromatic like benzene. If we said, pick the ones that are unsaturated, you wouldn't pick benzene on the list either. But in terms of their reactivity, they behave like saturated molecules. Because remember, saturated molecules are less reactive than unsaturated ones. So these guys are not very reactive either. So in terms of their reactivity, they behave like saturated, but they aren't part of the category. They aren't really part of either category. Now, how do we name them? So the benzene ring will sometimes act as the parent chain, or it will sometimes act as the branch if it's a larger molecule or one that's a little bit harder to name. So if it's acting as the parent chain, then benzene is going to be the backbone of the molecule, and we can name these things as groups. So I've got one group here, I've got one group here. each of these groups has got 2 carbons in it, so those are ethyl groups. And there are 2 of them. Now, just like with the cyclic compound, I start numbering at one of the groups and I number towards the next one. So 1, 2, 3. So this would be 1, 3 diethyl benzene. Now, in this case over here, I can't name this thing as a group because I don't have any way of naming that in the organic naming that I know, right? It comes off and then it kind of branches in both directions. I don't know how to name that. So I'm going to name then this as the backbone, this straight chain section as the backbone, and the aromatic benzene ring is going to become a group. So when benzene is being named as a group, it's called a phenyl group. So this is a phenyl. And then I would number it on the backbone like I have before. So this backbone's got 1, 2, 3, 4, 5 carbons. We number from the side closest to the group. 1, 2, 3, 4, 5. So this would be 2 phenyl pentane. Okay, so you have to evaluate if you can name it as the backbone. If so, you do. And then it's a benzene backbone. Otherwise, it can get named as a phenyl group. So why don't you try naming these ones, and I will pause the video here and try naming these example ones. I will name them, and then I'll put them up here and meet up with you. Okay, hopefully you gave those a try. So the first one, I can name the benzene as the backbone. So as I number around the ring, it would be 1-ethyl 2,4-dimethylbenzene. Now this one here, we're showing you a new type of structure. When we put CH2 it means that there are 3 of these CH2s in a row. We just run out of room, or maybe it's too big and bulky. We don't want to have to write the whole thing out. So there are 1, 2, 3, 4, 5, 6, 7, 8 carbons in this chain. So it's an octane backbone. There's a propyl on carbon 4, and there's a phenyl on carbon 3. When you're putting these groups in front, they go in alphabetical order just like they did before. So the P is the same, but the H comes before the R. So the phenyl would come first. So this guy's name would be 3 phenyl 4 propyl and octane. And then for this guy here, I'll pause it again and fill it in, and you can check it. So my top one here is 4-phenylheptane, pretty straightforward. Heptane backbone, phenyl on carbon 4. This guy, I got 2 phenyl groups, a methyl group, and a double bond. So it will be 3-methyl 5,5-diphenyl oct 1-ene. Then give this one a try too. So this would be a common diploma style question where we give you some organic compounds and we ask you to choose the one or ones that meet these criteria down here. Looks like my box is cutting things off. Let's see if we can fix that. So in case you can't see it in your booklet, I'll expand it here. Here's some organic compounds, and then you can match them up here with the descriptions, the proper descriptions of them.